This is the International Space Station, 280 miles up, passing overhead here at Jodrell Bank just a short time ago.
Yeah, the 6 astronauts on board are currently the only people in space. I've been talking to them as they orbit the Earth at 17,500 miles an hour.
Also tonight, the best free show on Earth, a meteor shower.
I'm Brian Cox, he's Dara O'Brien, this is Stargazing Live.
Welcome back to Jodrell Bank in Cheshire for night 3 of Stargazing Live. Coming up later, we'll be meeting the next British astronaut going into space. And if you're with us for the first time, well, you're joining what I think personally is the highlight, the greatest free show on Earth, a meteor shower.
Yeah, this guy here, believe it or not, is older than planet Earth.
Yeah, they can pop up anywhere. As we discovered last night while filming something completely different over Mark's shoulder, you saw him there. Hawkeye Mark Thompson is outside again, hopefully keeping his eyes peeled a bit more because he's got an extra set of eyes. And he's with Jonathan Ross. Hello, Jonathan, how are you?
I'm very well, Dara. How are you? Nice to be here. Thank you for having me.
I know, one invite. Come up and join us and stand outside and be cold.
Yeah, please do.
How are you guys, you all right?
It's very, very good. Now, you didn't see it last night, Mark. You saw it afterwards. Were you surprised?
Yes, I was. I was completely oblivious to it. I gathered a number of the chat sites went mad for the appearance of this thing over my shoulder, and of course I had no idea what was going on.
It
I
was
seemed to
people,
make a career out of
contacting us live who told us that thing had happened. And what are we going to see tonight?
Well, unfortunately it's cloudy, but we're out here in our field at Jodrell Bank. I've got Jonathan with me. Now, last time we met, Jonathan, of course you have 3 complex computerised telescopes.
Thanks for reminding
You
us.
didn't really have much of a clue around how to find a way around the sky.
Because I tried and failed, frankly, but you took me by the hand very gently, very kindly, and now I do feel like I have the confidence to go out on my own. But you know, it was less cloudy about 5 minutes ago. We could see
Yes, it
more
was.
about 5 minutes ago.
So do you feel like you've learned more?
I think, well, obviously I couldn't have learned less. I mean, I clearly knew next to nothing.
you come away knowing something.
I think I can spot the occasional star, and even if I don't get it right, I'll bluff with a degree of confidence that will surprise me.
Little test for you. Do you remember this?
I do. It's the planioscope.
The planioscope.
Planiosphere thing.
Commonly known as a planisphere. Could you set it up for me?
Well, right now?
No.
Well, I can't because
You
you know
remember
I've
how
got
to
a good
use it.
excuse because I can't see the stars, so I can't find the North Star. If I could find the North Star, I could, because I set this, find
Yes.
the North Star,
Yes.
and put the time and date in matching, line it up, bingo.
So you have learned something.
Also remember
Your
it.
experience.
And I watched it back 2 nights ago.
And you've been revising, haven't you?
Yes.
How dare you, sir? You've been revising.
Because I'm interested in it. You've opened my eyes. I've read books and stuff. I know much more than I ever knew before.
Oh, that's great stuff, that's great stuff. Well, if the skies do clear tonight, then do hang around because there are still some amazing objects in the sky that you can see. Certainly most of them are easily findable. Findable? It's not even a word, is it?
Foundable.
Some great objects that you can find for amateur astronomers. Certainly people like Jonathan can pick them up easily, so hang around and hopefully we'll see something new.
Yes, there'll be more from Mark Johnson and an entire universe of findable things later in the show. He's also got real-life astronaut Major Tim Peake joining us later.
Yeah, you know, I met Neil Armstrong recently.
Yeah,
It's one of the most astonishing moments of my life. Actually, there's some kids there as well, and one of them asked him, they said, what did it feel like, you know, when you landed on the moon and you were running out of fuel, you had about 10 seconds left, you landed on the Sea of Tranquility. And he said, you know what, when the needle is on empty, there's always a bit of gas left in the tank. And then he got a standing ovation. It's the right stuff. Anyway, if you've got a question that you'd like to ask Tim, or anything else you'd like to know, within reason, of course, email it to us at stargazing@bbc.co.uk.
Or you can join in our live blog, Talk Stargazing, at the website. And please keep your pictures coming into the photo group. They've been fantastic so far.
Well, all this week, Liz Bonin has been in Hawaii for us. It's one of the best spots for astronomical research on the planet. And today, Liz is going to show us why. Hi, Liz. Where are you?
Thank you very much, Brian. You joined me at the very top of Mauna Kea. Check this out. 13,846 feet. Now, we've got about 60% oxygen here, which means that I might talk a bit of nonsense, so please forgive me. I'm trying to breathe as much oxygen as I can, but take in this view. So many telescopes from so many countries. To my left over there, the silver one, that's the Gemini, USA, Great Britain, Canada, and a few other countries. Over there, that little silver one there is NASA's telescope. To my right, the 2 beautiful USA Keck telescopes. Beside that, Subaru from Japan. And down there, the thing that looks a bit like a pillar box in white, is our very own Best of British JCMT. And look at it. You can kind of get why all these telescopes are here. The clarity, the atmosphere, the climate is perfect to get a view of the night sky like you wouldn't get anywhere else on Earth. Of all the stars that the Earth can see, we can view 80% of them from right here. And I got a chance to do just that at the very top of this mountain during the night sky. Beautiful stars. Take a look at this. Being a novice, I've asked astronomer Josh Wollevender to join me at the top. Josh works at the University of Hawaii and knows everything there is to know about the night sky. Hey Josh,
Hi,
nice to
Liz.
meet you. How are you doing?
I'm doing good.
It's already looking pretty spectacular up there.
Yeah, we're right at the end of astronomical twilight. It's finally fully dark, and
Okay.
we can see just about everything we're going to see tonight.
We're going to
And
see some good stuff?
It's going to be fantastic. So tell you what, why don't we grab the camera and take some pictures and start playing around with it?
Fantastic, let's go. as twilight gives way to complete darkness, it's easy to see why all these telescopes are here. The sky lights up with more stars than I've ever seen before. So on a night like this, what are the main things we can see with the naked eye?
Well, what's really spectacular from here is the Milky Way. And if you look over this way, you can see sort of a, faint milky band moving through the sky. And this is all the distant stars in our galaxy. So here's the wide-angle shot. You can see the Milky Way. And what we can do is zoom in here, and part of the Milky Way, right next to it, is the constellation of Orion. And if you look very carefully, the central star in that sword of Orion,
Yeah.
you see how that's kind of fuzzy?
Yeah.
That is an area where stars are being born. This is called a nebula.
Oh, yeah,
And that
fantastic.
fuzziness is a cloud of gas and dust. And that cloud is the raw material of star birth.
He is surrounded by so many stars. It's literally overcrowded on a night like this, isn't it?
Right, when it's really dark like this, when you're in a dark sky site, the constellations are almost harder to pick out because you see so many stars. All right, what we're going to take a look at now is the actual farthest thing you can see with the naked eye. What it really is it's another galaxy. So just like our Milky Way is a big disk of 100 billion stars, the Andromeda Galaxy is another galaxy about the same size and shape as our own.
Oh my gosh.
And there's the galaxy. You can see that it's got a bright central core. You see the wings coming out to either side?
It is so beautiful.
And so the disk is almost edge onto us, so you can see it stretched out to either side. That light that's hitting your eye, that you're seeing, that little fuzzy patch, that light has been traveling for 2.5 million years to get here.
That's just mind-blowing.
The brightest thing that you can see up in this direction is the planet Jupiter. You see that there's sort of a pillar of light coming up towards it? It's called zodiacal light. And this is dust in our solar system, in the same plane as all the planets. And that dust is the raw materials out of which the planets form, out of which Earth formed. And that is being lit up by the sun. So it's night here, but the sun is shining on that dust. So we've looked at two disks here tonight. One was the flattened disk, which is our solar system, and the Milky Way, our galaxy, which is 100 billion stars.
Stunning, stunning. This is just blowing me away. It's only when you come to a place like this and you see it all with your own eyes that you get a real sense of our place on this tiny rock amongst it all. And it's really humbling. Two words for you. Awe-inspiring. What an incredible night. But of course, here on Mauna Kea, we can see infinitely further than the naked eye thanks to these incredible telescopes. So later on, I'm going to be speaking to the director of this one, the British UKIRT telescope, Mr. Gary Davis. And we're going to be talking about the incredible work UKIRT and JCMT are doing to view galaxies as far away as 13 billion light years away. See you very soon.
Okay, thank you very, very much, Liz. Liz, by the way, handling the altitude a lot better than you did.
You know, I filmed up there, and I've done it several times, and we've never used any of it because it's high. It's almost 5,000 metres. Your oxygen's starved, and it is extremely difficult to do anything other than laugh. Basically, you feel drunk, and you literally fall over. So it's done incredibly well.
Lovely stuff. Okay, now we asked you before about you to send in pictures. They have been fantastic. The pictures have been brilliant. This is from that's a comet, for God's sake. Comet of Wiltshire.
From Wiltshire. And then we've got that.
Now, Jupiter's been a bit of a perennial favourite. Also, the shadows, which we saw as well, of its moon,
Yeah,
which is very
I mean,
beautiful.
that's a big telescope, isn't it, from Bob Trevan in Basingstoke. And that's the Milky Way.
That's a beautiful shot.
I mean, I never tire of looking at the Milky Way. I mean, that's our galaxy. That's billions of suns, a cloud of glowing starlight. Absolutely beautiful.
And this is a particular one. Now, that is the best shot we
quadrantes.
got. In the Isle of Lewis, up in the northern islands in Scotland, a shot of one of the meteors here now. Because the quadrantid, a lot of people are asking, why is it called quadrantid meteor? Why is it called that?
Well, you name meteor showers by the point in the sky that they appear to come from. So we've got a map here of the quadrantid shower. The reason that we call it the quadrantid is it comes from this point here. You call it the radiant, which is in this rather obscure constellation. It's called Quadranis. I've written it down, actually. I never get it right. Muralis. I never heard of the thing, but I've heard of the quadrantid.
But they don't come from that constellation. They just happen to appear to be.
What's happening is that the Earth is passing through a region of space in the solar system that has got a dust and debris in orbit in that particular place. So it's passing through a band of dust and debris. That would probably have been left by a comet. So it'd probably be a tail of a comet, essentially, just left there.
And the tail is basically debris that gets blown off the comet by the sun.
Yeah, so you see this strange thing with comets, actually. As they approach the sun, you see the tail behind them, as you would expect. But as they swing around the sun and go out, you see the tail in front of them, as it were, in the direction of motion, because it's a solar wind that's blowing all these.
And these things
icons.
aren't huge. I mean, that huge bright arc of light that we see, right? That's like they're tiny things, aren't they?
Oh yeah, I mean, this is really literally dust of a comet. So they're usually about, what, a grain of sand to a pea.
I mean, they're
at most.
brighter than any star, shooting across the sky.
Yeah, and this will be something smaller than a pea and probably a grain of sand burning up in the Earth's atmosphere. You see how much energy is involved, actually. So when you get hit by big things, like that thing I had in my hand earlier, you can see why they make a big crater.
Because
or a big hole.
Okay, no, because it is, and also it's one of these phenomena that you don't need any kind of telescope for. It is just sit and watch it.
It's a beautiful thing, and I think again, it's one of those things that if you know what it is, it's even more beautiful. I mean, it really is the debris from a comet. It was probably something that was formed 4.5 billion, nearly 5 billion years ago. That's been orbiting the sun. It goes out to the icy reach of the solar system and back again, and we're passing through the tail of them, and you see them as shooting stars. stars. It's
And
very
that's
beautiful.
all in the sky. Now, meteor showers happen throughout the year, but getting to see them, of course, is weather dependent. Mark went out with a group of amateur stargazers from East Anglia last month to try and spot the last meteor shower, the Geminate.
It all looked so promising. As we headed out, there was clear sky above us, and Orion was looking down. But as we set up our deck chairs and wrapped up in blankets, the clouds rolled in. You must find it quite frustrating with coming here all this way to Suffolk to try and see the meteor shower, and of course it's now clouded over. What do you get out of it?
Oh, it's not uncommon to be beaten by cloud. It's one of the very frustrating things. I spent many nights trying to observe and being beaten by the cloud, but it's still the camaraderie of the groups of people.
Mandy, I mean, this is your first meteor shower. The clouds have come in again. Typical story for the UK. How does that make you feel?
Frustrated, disappointed.
Yeah.
I really hope to see much more, but that's the way it goes, I suppose. It's not put me off. I'd definitely come out again.
Yeah, we can hope that it clears up tonight and we get something later on, but we'll keep fingers crossed for that. And so we waited. And waited. And waited. And then, just as we were about to call it a day...
That's a big one.
Another one! Oh, did you see that one?
Well, Jonathan has joined us inside. We're talking about meteorites there, the stuff of science fiction. I just want to show you this before we talk in detail about them. Look at this picture. Now, what do you think that is?
It looks like our moon, but I imagine you wouldn't just show me a picture of our moon. So probably
No, it's Mimas. It's one of the moons of Saturn.
also looks like the Death Star from Star Wars.
Doesn't it?
That's what it does, and that's the interesting thing about this, because look at the size of that impact crater. I mean, it's on the verge of blowing that moon apart. It's about as big as it could be. But if you look at the surface of that, it's completely covered in craters. That thing's been hit by so many things.
There's a big one down the left,
history.
isn't
There is. It's on the verge of being blown apart. But then look at this picture. Now, that could be the surface of Mimas again,
Yeah, or the moon, or
or the moon, except for the visitor centre. It gives it away on the top. So what that tells you, this is Earth.
I think
This
that
is
was a
the
near
very-
miss. They were very lucky in there, weren't they?
Great that
Imagine if someone was having a cup of tea and the thing fell out.
But they were getting no business in the visitor centre.
I'm thinking, what are the chances of that?
Whereabouts? Where on the
That's
planet
a
is that?
Barringer crater in Arizona. Now, you don't see many of those on the surface of the Earth, but that does not mean that the Earth doesn't get hit a lot. In fact, it gets hit, it has been hit in its past as often as Mimas. So it should look
And is
like
it just
Mimas.
because we have weather, basically?
Yeah.
That we have an atmosphere and wind and that it covers over.
So they get eroded away, but because this is in a desert and it's relatively recent, only a few thousand years old, it's still there.
Now, these are some examples of, well, they're not all meteorites. Do you want to lift that? That was the one we showed earlier. Do you want to lift that?
Wow, it's much heavier than you would think.
Yeah.
What is it made of?
That's iron, primarily.
It's heavier than Earth iron.
That's
No, no. There's only one kind of iron.
Mars iron.
Well, I mean, iron's the most abundant heavy element in the universe, because you might say, why is it made of iron? There's a lot of iron out there. The thing is, on the Earth, though, it's all in the core. Whereas this thing, I should say, I said at the start, it's one of the most ancient objects. It's older than anything on Earth, this.
Now, how can it be older than something on Earth? Surely we're all of the same age.
But we're all made of the same bits that were in this cloud just about 5 billion years ago that collapsed into the solar system. But the Earth's rocks, I mean, this is actually an Earth's rock here. You feel it, it's much lighter.
Yeah.
It's
Well,
a
it's nothing
volcanic
compared-
rock.
smaller, of course.
So our rocks have been constantly remade by the geological action of the Earth. So
how
there's
old is
nothing
it?
that old.
How old is
This is probably over 4.5 billion years old, probably approaching
And Robinson
5
signed
billion
it.
years old.
Yeah.
She must have been at school with this.
Private collection.
It's in the desk.
Well, you can see, I mean, so that landed on Earth. Actually, you've got the details of it.
Indeed, that was found in Namibia in 1838, and it was just used as an iron source, the rest of it, by the locals for that. And this one that was found in Oman in 1992, but landed about 10,000 years ago.
But these are much bigger than the ones you were just talking about. You said they were like pea size.
Oh, yeah,
So
the
these were
shooting stars that we
caused
see.
a big crater.
Well, these, I mean, things that leave bits like that. I mean, you're talking about extinction events. So there's two things these things can do. Right? The dinosaurs got wiped out by 165 million years ago, which completely changed the Earth's climate. But there's a very interesting theory, which is pretty widely accepted now, actually, that when the Earth formed, so it's very early formations, a few 100,000 years, then all the water would have disappeared from the Earth. It would have just got blown away by the sun, essentially, and gone out into the distant solar system. So we think that things like this, well, comets and meteorites hitting the Earth, brought the water back to the Earth.
And what about life? Did they bring life as well? Is there a theory?
Well, there's evidence in some of these meteorites that you can see amino acids, which are the building blocks of life, in the meteorites. So the basic building blocks of carbon chemistry formed out there
Are
in
you not
space.
scared we're going to be hit by one of these things?
I tell you what, if you weren't so good looking and smiling all the time, people wouldn't want to hang out near you. Because all you do is go on about rocks breaking the Earth and we're going to get hit by one, we're going to die, look at that planet, it's virtually
It's what they
falling
used to
apart.
call the baby-faced assassin. Ole Gunnar Solskjaer was a great Manchester United.
I know. Yeah, listen, before we get apocalyptic again, which is all we do in this show, let's go to the man who genuinely is having a miserable time. By the way, thanks to Open University for lending this to us. Let's have a word with Mark outside.
I'm having a fantastic time, but it's still cloudy. We're being teased by clear spells, but they're not very big, unfortunately. I'm sure there are areas around the country that are getting some clearer skies than us. Now, you don't have to be experienced to get involved in Stargazing Live. If you're new to astronomy, then there's loads of fantastic free activities you can download off our website, bbc.co.uk/stargazing. You can download a free star guide, which shows you what you can see in the night sky throughout the year. And I've set up some audio guides, which show you what you can see in the sky throughout the seasons. So there's loads of things you can download, events up and down the country, but now back to you in the studio.
Well, as we saw with the Andromeda Galaxy image last night, viewing space in different wavelengths reveals unseen levels of detail. The Lovell looks at the radio wave part of the spectrum. So Dara took a trip up the dish to find out how it works.
Oh, that is petrifying. I'm on both handlebars. How tragic is this? Oh. Live dance on the roof of a lighthouse, and this is more frightening. Oh my God, that's weird. That is strange. So how exactly does this work?
It's this huge ball, collects radio waves that arrive from, as we're standing here, from directly above us, and they reflect off that curved ball, and they head up towards the top of this tower in the middle.
So the shape of the dish means that everything that comes in bounces back up to that point.
Back up, but it's all combined. So basically, you know, effectively like your car aerial.
So what have you brought to show me here?
This is a picture taken with an optical telescope of a patch of sky in the constellation of Cygnus.
Okay, so that's what we could see through a telescope.
Yeah, it's really nothing obvious. It's just loads of stars.
Loads of stars, yeah.
But what I'm going to do, I'm going to zoom right into the middle of that picture. What we're interested in here is that fuzzy blob there.
Right.
That fuzzy blob is actually a complete whole galaxy, almost 1 billion light years away. But when we look at this with a radio telescope, it's actually one of the brightest objects in the whole of the radio sky. And this is a view taken with a radio telescope.
Jeez, is that the same thing?
Exactly. So this
in exactly
the same scale between these two pictures.
And in the radio telescope, all the stars have disappeared, so we're not seeing any of those.
So you're just not seeing the stars. It's what you see is the black hole that sits in the middle of that galaxy.
Wow.
And that black hole shoots out 2 jets of material. And where those jets crash into the stuff around the galaxy, there's basically a big splash, loads of energy produced, and it produces these incredibly bright hotspots of radio emission.
That is genuinely incredible. And up until this was built, 50, 60 years ago, we didn't know that this was even happening up there.
You don't get the full picture unless you get all these different wavelengths.
And it's a whole new universe. That's incredible.
Well, Tim's back with us again. You, of course, work at the Lovell Telescope, but you're also working on a project that makes that look like a little toy.
I know, we're a bit greedy, really, actually. We'd really love a much bigger telescope than this one. In fact, we'd love a telescope the size of England, because what that does is it gives us a sharper view. It works a bit like a zoom lens. The bigger the telescope you make, the smaller details, the finer details you can see in space.
Put a funding bid for that?
We've tried. You know, we've not back a few times, but we've done some bits of it, actually. So we've actually got this telescope called E. Merlin.
We've got a picture here, actually.
Yeah, it's actually 7 radio telescopes spread across the country. We'd have liked to have had a telescope, you know, 217 kilometres in diameter, but, you know, people in Birmingham would complain, I think.
Birmingham's about here, is it?
Is this still the equivalent? Because I've heard about these arrays before. Is this the equivalent of having one that big, but just having a panel here, a panel here, a panel here?
Exactly. You've got to imagine a giant telescope that size, but in fact, we've only built 7 little bits of it.
So how do you fill in the gaps?
Well, what you fill in the gaps, actually, you work with something called Earth rotation aperture synthesis.
Right.
We actually allow the Earth to spin round as it continues
Everybody
to do.
knows what that is.
Of course they do.
You know, but for the two people who don't, okay?
So the things move across the sky, and as they move, that fills in the gaps, and that lets us make the image that we can see.
So what's the real advantage of this then? Because you just look naively and just think, well, you just get less light than you would with a big telescope. It's obviously true.
Of course, but there's 7 big telescopes. You're getting quite a lot of light, but the advantage is the sharpness of view that you get. It's a sort of zoom lens. It sees right in to the hearts of galaxies in distant space. It sees through dust clouds. It lets us see distant objects.
To test out this incredible new technique, we thought we'd see what one single object would look like when observed by the new E. Merlin network. We asked him to pick a subject, and he decided on a star-forming region called Messier M82, more commonly known as a cigar galaxy because of its shape. Now, to get a kind of a contrast, I fancied having a go myself, imaging it. So I booked some time online on the Fawkes telescope in Hawaii, which anyone, by the way, can do. This is incredible. Anyone can book time with this telescope. Go onto the webpage, type in the part of the sky you want to take a picture of, and it will image it for you. Now, it takes a while to process these images, and I haven't seen them yet, so I'm actually quite excited.
But I've got it here. So this is your image of the cigar galaxy.
There we go.
Page 38
and a half, to be honest. Yeah. So that is, and what is that now? That is this is an explosion.
So this is a disk galaxy, a spiral galaxy seen almost edge on, but there's something shooting out of the middle of it. That red stuff's actually hydrogen gas. It's shooting out in the middle because something violent's happening in the middle of that galaxy.
But we genuinely didn't know what that was because it's obscured and
things called
visible.
There's dust clouds. You can see them there, the dark patches in the middle there. The dust clouds block our view of what's happening in the middle.
And so your aim there, and we'll see this in the next picture, is to see through the dust, is it?
Absolutely. And what this picture, I mean, I know your image was good, but this is a Hubble Space Telescope picture of the same thing in the background. And what we've done is we've overlaid in the middle what our Merlin telescope can see looking right into the heart of the galaxy.
Yeah, I don't think we've got a close-up of that. So this is looking through the dust. This is a radio image.
This is a radio image looking through the dust, and what you can see here, there's emissions spread across the whole of the galaxy, but there's also these little spots that you can see. The bright spots are actually stars that have exploded in the last few hundred years.
There's a supernova explosion.
Supernova explosions. There's a huge amount of...
Why are there so many supernova explosions? There it is.
So this is actually what we've done here is we've combined the previous Merlin image of a few years ago with a new Merlin image that we've taken just this week. We're actually observing M82 as we speak.
This is fascinating because I know there's about one supernova per century per galaxy on average.
Typically, yeah.
Why so many?
So many in this case because actually this galaxy's come very close to another nearby galaxy called M81, and the tidal interaction, the gravitational forces between them have caused a burst of star formation in recent history.
That's really fascinating. Yeah. And then just the last thing, I know you told me about this dot here, which was particularly fascinating.
That's the thing we're keeping an eye on because that appeared in 2009. It's slowly getting brighter and we've no idea what it is. It doesn't behave like a supernova, we're not sure what that is, so we're keeping a close eye on it.
Radio astronomy is utterly fascinating. We have no idea what that is. Well, that is radio astronomy at its best. Now, Liz is standing by outside one of the leading infrared telescopes in the world. And even though it's in Hawaii, it's British.
Thank you very much, Brian. Mauna Kea is the international mecca for astronomy, with 11 countries running 13 telescopes, and I am inside the best of British, the Ukert telescope. And I tell you, it is just amazing in here. Now, Professor Gary Davis is with me. Gary is the director of Ukert. Tell me, first of all, about its incredible piece of kit.
Hello, Liz. Well, this is the United Kingdom Infrared Telescope.
Yeah.
It's one of the largest telescopes in the world to study infrared radiation, and we've been operating since 1979.
Incredible. Now, it is the largest dedicated infrared telescope in the world. Why infrared?
Well, infrared light gives us information about the universe that optical light can't tell us.
Okay.
And in particular, we study cool objects with the infrared. Cool objects that we can't pick up with visible light.
Fantastic. So what kind of things are we looking at then?
Well, I can give you an example. One of the things we specialised in is an object called a brown dwarf.
Brown dwarf?
Brown dwarf, that's right. And that's an object that forms in the same way as a star does, the same way our sun does. But it's just too small to start nuclear fusion in its interior. So it doesn't burn, it just cools off gradually. And so they're very cool, faint, and dark. And so they're called a brown dwarf.
Incredible.
And we can see them with Ukert.
I mean, the equipment here is very awe-inspiring. Tell me about the working parts. Where were they made?
Well, this is all British. The primary mirror there is 3.8 metres across.
It's so shiny and clean.
Oh, I know it is. This is a case where size matters. Size of the mirror is very important. And that came from Newcastle.
Yeah.
The steelwork came from a company in Sheffield, based on the steel industry. And that big black object, which looks like a missile, is actually a very specialised infrared camera.
Gary, it just goes to show that the British rate quite highly in the world of astronomy then. This is the best of British doing incredible work, right?
That's absolutely right.
Fantastic. Now, you're also the director of JCMT Telescope, and Gary was very, very generous and allowed me to meet one of his scientists, Dr. Serena Vitti, to see the kind of work she's doing inside the telescope last night. Take a look at this. So, Serena, what exactly are you working on in this telescope?
So we are observing the so-called dwarf galaxies. These galaxies were supposed to be the building blocks of much larger galaxies. They were supposed to be quiescent, not forming many stars. And then suddenly we realize instead that there are bursts of star formation going on. And we don't understand why, we don't understand how. And carbon monoxide is the key to understand the star formation in these galaxies, because stars come from gas, and this carbon monoxide is tracing the gas. So our aim is to map the whole galaxies to basically see where stars are forming in this galaxy.
So how far away is this galaxy?
It's around, well, 50 million light years.
Whoa, incredible. And do you have a cool name for it yet?
It's called NGC 1569. So I'm not sure.
Can we call it Liz?
Go ahead.
Look at this, my very own graph. I was a bit of an astronomer for one night. This is what matters. We can see beautiful images of our galaxies and stars, but this is the real science right here. This peak of carbon monoxide shows that we're opening up a new tangent in our research. These galaxies shouldn't be producing so much carbon monoxide. It's fascinating research. I'm going to frame this when I go home. Now, Gary is still with me. Gary, tell me quickly just about JCMT. It works differently to the Ukert, doesn't it?
It does. It's sensitive to a different type of light. We call it submillimeter light. And so it has to use a different technology to pick up that type of light.
So it's submillimeter wavelength. What kind of things does it see?
It sees extremely cold objects, whereas Ukert looks at cool objects. The JCMT looks for very, very cold objects in the universe.
Incredible. Well, we're going to be talking a little bit more about deep space astronomy very shortly. Gary's going to stick with us. Come back to us soon.
Now, over the last 2 nights, we've shown you Jonathan Ross attempting to get his head around basic astronomy. Before we find out how much of it he's actually taken in, here's a quick reminder of how we got on.
When we first met Jonathan, we showed him how to see Jupiter through a telescope.
Incredible. Well, you can't go for you. You've done this before, but it's incredible for me.
Then we showed him how to find the plough in the night sky.
That's the plough. No, that's near
You're
the
heading the
bow.
right way, you're getting warm.
There.
Bit more.
Over there.
Just a hint, keep going.
Just about.
And with the help of the planisphere, he was able to find his own way around the constellations.
Oh, I see. That's why we bothered with the whole
Yes,
pole star
yes.
business.
So that now
All right,
shows
Mark,
you-
forgive me. I thought you were just showing off.
So we filmed that a couple of weeks ago. How did you find it?
It was exciting. I mean, it was something I've always wanted to do. And as you know, I was given that telescope to my wife. I wanted to use it. Had tried a few times. You know, I tried and kind of failed miserably.
Yeah.
So having Mark there, he was very kind. He put up with all my nonsense and patiently showed me how to do it. And it was exciting to finally see
And
something.
how did you find it? Because I know when I look through a telescope and you see it in real time, so you really see an image of Jupiter or Saturn or one of the Andromeda galaxy. For me, it's different to see the image on a screen. There's something about that connection.
Yeah, that's the best thing about it, is the feeling that you're actually seeing it. I mean, it's not... Here's the thing, I found it in some ways a little underwhelming. And it's maybe a little churlish for me to say that, but I'm so spoiled by seeing the pictures like you've been showing tonight, where you see the colour, and you see these pictures from Hubble and all these other telescopes, and you see these explosions off the planets and the stars. To actually see a white dot in the sky with your naked eye and then see it maybe 4 times bigger through a telescope wasn't quite as impactful on me as I thought.
It does help if you know what the white dot is or where
it
the
was
white dot is.
exciting.
Yeah,
It was
a little
exciting.
bit of knowledge is one of the things that does help to enrich the experience.
And knowing a little way, now I feel that I can find the North Star, I can see where Orion's belt is. That's exciting. I know that's quite simple to you, but for a newbie like me, it was exciting.
Well, no, and I hope it's the kind of point of this programme, actually, because I do think that there's something, I say, about just really seeing those things.
Just going, look, I know what that is.
Not even through a telescope, even just seeing them with your eyes. I think there's something special about it.
How much knowledge have you retained?
I think I've retained a bit. I hope I've retained some.
Yeah. Names of the planets?
All of them?
Yeah, go on.
Well,
Yeah.
all in our solar system, or all of them?
Not all 500.
That's a good question, because there are about 500 planets known now around distant stars. So go on.
Not all 500. Okay, Mercury, Venus, Earth,
Yeah.
Mars, Jupiter, Saturn, Uranus, Neptune. No longer Pluto. That's been kicked off.
Yeah, gone. Absolutely gone. Well
No
done.
longer
Very
Pluto.
good. What's between Mars and Jupiter?
Between Mars and Jupiter.
Yeah.
I just told you that.
No, there's a thing. Yeah. What's
Between Mars and Jupiter? Yeah, Hubble.
No, there's an asteroid.
It's the asteroid belt. Yeah, so in a sense, it's a failed planet. It's not possible. It's because of Jupiter's gravitational interaction with that region of space.
So it's holding it there?
The planet can't form, so it stays
Can't go
there.
that way. Can't go that way.
What's the hottest and what's the coldest?
Well, I'm tempted to say Mercury's the hottest. It's nearest the Sun, but I'm sure that's a trick question. So probably
It is, yeah.
But it'd be one fairly close to the Sun. I'm going to guess Jupiter or Saturn.
They're not close. They're...
I know they're a long way away, but they might have an
Venus.
atmosphere.
No, Venus.
It's Venus, and that's interesting because when that was discovered, it was one of the first examples of a greenhouse effect. So part of the reason that exploring Venus is interesting is to understand the greenhouse effect on Earth, to understand things like climate
Here
change.
you go again,
global
doom and
warming.
gloom. Every time the answer is now.
I'm telling you about the profound usefulness of curiosity-led
Yeah, but there is
science.
something that we have at least 3 times over the course of these 3 days gone, this may kill us all. Sometime in the next 100,000
We live in a
years.
dangerous universe, and that's one of the reasons why exploring it and trying to understand it is worthwhile.
People
I
have
forgive
not-
you because you're so smiling.
It's the only thing we ever done a Sky Television that has to end like Crime Watch. Don't have nightmares. This might not happen during you or any of the humans' lifetime.
Can I say something? Stop about it, but as a viewer and a licence player, and let's face it, that's essentially my relationship with the BBC now. This has been a great show to watch. I've loved every second, seeing the last 2 nights and tonight being here as well. What a great show, a great job you've done, and so great to see this kind of thing on TV in virtually prime time. So
You're
it's
very, very
fantastic.
kind. By the way, did you see anything mad, anything weird out there, anything unexplained when you're out?
Not recently. Apart from Mark, you mean him?
We haven't found a reason for him either. Mark currently himself is outside with some interesting phenomena that we caught on tape.
Yes, we captured this amazing footage on camera earlier, and it may look a bit strange to see moving lights in the sky. A UFO, I hear you cry, but actually no, they're really satellites. Now, satellites can be seen on any night of the year, and we think they probably account for a number of UFO sightings, but people just don't realise that you can see satellites from down here on Earth. Now, if you want to see your own satellite, there are plenty up there to be seen, you can find plenty of websites which link you to the times and the dates and where to look in the sky of those satellites. Now, if you look at our website, bbc.co.uk/stargazing, you'll find links to all those sites.
Okay, thanks to those sort of websites that we were also able to catch this on camera because we were given a heads up about that is the International Space Station.
I mean, I can't believe that. And I was just told by the cameraman that the lens that was used to film that is the lens that's used to film Match of the Day, and it's going to have to film the United match at weekend. Well, that is a better use for it. I mean, no, genuinely. I mean, I look at that and I think that's what we can do if we want to. That's a spaceship.
And that's like about the size of a 5-bedroom house, 280 miles above our head.
It's utterly beautiful. But anyway, it's hard to imagine what it must be like living and working up there. So last month I got the chance to ask the astronauts for myself.
0 and liftoff of Endeavour. East and west tubing at the International Space Station.
Travelling at 28,000 kilometres per hour and 400 kilometres above the Earth, the International Space Station is the largest artificial satellite that has ever orbited our planet. The ISS functions as an observatory, laboratory and workshop, where astronauts from around the world have been living on board in zero-gravity conditions for the past 10 years, some staying up there for more than 6 months at a time. A couple of months ago, I was offered the chance to speak to the astronauts on board, and it wasn't an opportunity I was going to turn down. even though at the time I was in the middle of Africa. I'm just a few minutes away from talking to the International Space Station, which is something that I've never said before. Phone call to space. Now, I remember in 1981, the first space shuttle launching, John Young and Bob Crippen piloting it. It's etched into my memory. So to make a phone call into space, into orbit, just to speak to them, just to have that small connection for a small piece of time with that greatest of human endeavours, excites me. Standing by were Flight Engineer Scott Kelly, Commander Doug Wheelock, and Flight Engineer Dr. Shannon Walker. Now, you might think that it'd be really complicated making a phone call to space, but actually, all I needed was an ordinary phone line.
Station Houston on Space Ground 2, are you ready for the event?
We're ready for the event, Houston.
BBC in the live Stargazing series, this is Houston. Please call station for a voice check.
Station, this is BBC Live Stargazing series. How do you hear me?
At BBC, we've got you loud and clear. Welcome aboard the International Space Station.
Thank you for speaking to us today.
I do think the space program is the ultimate human achievement. I genuinely do.
But how difficult is it up there?
No day is routine up here. Space always has a surprise waiting around every corner for us. Because we're orbiting the Earth once every 90 minutes, every 45 minutes we're getting a sunrise or a sunset. And in direct sunlight, we're seeing temperatures anywhere between 250 and 300 degrees Fahrenheit. And then when we go into eclipse on the backside of the Earth, the temperatures can plummet to 275, 300 degrees below zero.
And spacewalks, are they genuinely different feelings
from being inside the shuttle or inside the space station?
And you open that hatch, and the only thing between you and the vacuum of space is that thin visor. It's a real eye-opening experience. The most encouraging part of doing a spacewalk is knowing that you've got a team of people behind you, and you can hear them in your headset, and that's very, very comforting because there are a tremendous amount of things that can go wrong out there.
Dr. Walker, could you
tell me a little bit about what scientific experiments you plan to do when you're on board the space station?
Well, we've got a number of scientific experiments from just about every scientific field, from material science to astronomy to biology and human physiology. And so a lot of what I'm doing actually is the human physiology side, where I'm using myself I'm being used as a test subject to study some of the effects of being in space on the human body.
How would you answer people who don't think that human exploration is valuable?
As humans, we need to keep moving forward as a society and not stagnate. So we need to keep pushing the boundaries and keep exploring.
I wonder if we had a Kennedy today, a Kennedy-like speech that said, we choose to go to Mars before this decade is out.
Do you think that we've been in a position to do that? Do we know enough to make that next great
leap into the solar system now, if we had the will and the money?
Someday when we do go to Mars, the things we learn here on the International Space Station will be critical to that effort. And I'm somewhat of an optimist that, anything is within our grasp. And I think we could, go to Mars just like we went to the moon in a very short period of time in the 1960s. So I think it is within our capability to do that if we chose to.
Well, Station, we've run out of time, but it was a real pleasure talking to you all. Thank you. I think you are
genuinely inspirational, and please keep doing it.
Well, thank you very much for joining us, and it's a real pleasure for us to talk to you today.
That was wonderful, actually. I mean, they genuinely were talking about the inspirational value of spaceflight, the technical difficulty of it, but also the reason that you do it. As Kennedy said, you do it not because it's easy, but because it's hard.
It is truly awe-inspiring, and if you want something that genuinely will shock you, yesterday we had the partial solar eclipse, and we also got this photograph yesterday of the partial solar eclipse, the moon there, the sun there, some sunspots, but that, if we can zoom in, is the International Space Station. Not a TIE fighter, by the way, which everyone has gone on to me today on Twitter, but if you do, look at the sheer isolation of that.
Isn't that beautiful?
It is
that's a picture of what our future will be, if we can be bothered. What a beautiful picture.
To continue colonising
I really
space.
think it is. Well, 2011 marks a hugely significant anniversary in the history of space exploration. Any idea, Dan?
Yes, of course I know. It's 50-ish years since our first step out there.
That's right. 50 years since Yuri Gagarin, the Russian cosmonaut, journeyed into space, became the first man in space, in a spacecraft that was really no bigger than a spacesuit. I mean, it was a tremendously bold thing to do. I think the other thing to remember is that that was within one human lifetime of the Wright brothers. So we went from the Wright brothers to the Soyuz, the Vostok, the first spacecraft, in one human lifetime. Beautiful. Well, since 1961, over 500 people have been to space, but only a handful have been UK citizens. But just 2 months ago, Major Tim Peake, a former helicopter test pilot, became the first British person ever to complete the European Space Agency trainee astronaut programme. Before we meet him, let's take a look at him in training.
Now, this is presumably learning about buoyancy and coping with the weightlessness.
Yeah.
And mimicking that in water.
Yeah, and I've done that to some extent, actually. I did some fast jet training. They threw me into a pond in a flight suit, and I tell you, it's difficult. It's not as pleasant as it looks.
It's not just like diving. It's not just a very pleasant paddle.
It generally isn't. So I think we should go and chat to Tim about that experience. Tim.
How are you?
Alex,
Welcome.
Great to meet you.
Pleasure to meet you too.
Tim, when are you going to go up?
Well, it could be a long wait, but the European Space Agency has a good track record of flying its astronauts, so hopefully by the end of this decade I'll have completed a 6-month tour on the International Space Station.
And that's going to be flying in the Russian spacecraft, so the Soyuz.
That's right. With the shuttle retiring later this year, the Soyuz will be the only means of getting astronauts to and from the space station until that NASA comes up with its next generation of spacecraft.
And are you trained to pilot that spacecraft? So you can dock it. I know it's automated to some extent, but you learn in the same way that you learn to fly a helicopter.
We do. As European astronauts, we actually fly left-hand seat as Flight Engineer 1, and at that level you have to be able to take over from the commander, so you have to know how to fly and dock the spacecraft, the Soyuz, to the International Space Station.
And you may be up there for a couple of years. Are you then just keeping in training for, are you basically held waiting until you get your window?
To a certain extent, yes. The training never really stops. So there's always more training to be done on EVA, as you saw there, the extravehicular activity, and getting further Soyuz qualifications. But also, we've got other projects that ESA will get us involved in whilst we're waiting for our turn to fly.
And how much can training on Earth now with gravity actually prepare you for this?
Well, the best thing for weightlessness is the parabolic flights, and there you only get a short 22-second stint. But we go up for a 3-hour flight and get about 30 parabolas in, and that does prepare you to some extent for weightlessness.
Yeah, I just did one actually in Florida for a BBC series coming out in March. I can't do that again. But I went at 14 because they told us that actually more than 14, the average person gets sick. Well, you're a test pilot, so did you feel sick after 30 weightless parabolas?
No, we're very fortunate. There is only one person on the aircraft who felt
You wouldn't admit it, would you?
Yeah, you don't lose face.
But anyway, look, astronauts like Tim have to train for months, so we sent this fine specimen of a Mandara along to test lab to find out whether or not he could cut it in space.
Spending time in the weightless environment of space does really strange things to your body. It is no holiday up there. So I've come to King's College London to get an idea of what it's like.
And this is what is this?
So this is a tilt table.
Okay.
And so we can use this to replicate the fluid shifts associated with going into microgravity. And so what that has the effect of is bringing more fluid towards the upper body, to the neck, and to the head.
Well, listen, I think probably the only thing we can do is, well, strap me in. I presume. Feet here.
On you go.
Is there really any need for a 5-point harness? Like, I take it my velocity during this entire test will remain pretty much zero.
So this is what it feels like to be in space. This is a doddle. Astronauts train for months to do this.
What we're going to do is to use the pressure, your finger, to estimate the blood pressure going to your brain.
Right.
So in order to do that, what I'd like you to do is to place your hand with your finger next to your temple. So, are you comfortable?
Yeah, as comfortable as can be expected.
3, 2, 1.
Okay, what angle am I at now?
You're at 10 degrees head down tilt, Dara.
Okay, I'm beginning to feel, oh yeah, feeling on my cheeks. Do other astronauts talk about their cheeks? Being the first place to feel?
Do you have any difficulty focusing?
Yeah, I feel like I have to lift up my head. I just snap my eyes back into focus again.
And how about your neck?
My neck feels engorged.
Yeah.
This is all normal.
This is totally normal. And how about your forehead?
I'm beginning to feel a headache just here. That's common enough, is it?
That's one of the common locations.
It's weird. It's like having chubby cheeks, like I've stored nuts away for the winter.
Chubby cheeks, fat face. Yep, all quite normal.
All right, no need to get personal. Okay. Yeah, I've got the gist now. Is there any chance I can get back up against it?
Okay, I think you've had long enough. 3, 2, 1.
I can't get over the feeling that I don't look like an astronaut when you do that. I look like Frankenstein when you do that.
And that felt weird for me, just doing it for a couple of minutes. A proper professional astronaut will be up there for months on end, and all the time coping with fuzzy vision, headaches, and big red fat faces. Now, if that's not enough, there's something else that astronauts have to contend with. It's called space adaptation syndrome. It reduces your spatial awareness and cognitive performance, making all those really important space jobs doubly difficult. To show me what it's like, Dave has some yellow poles. This is a simple experiment for me to do.
the length of time it takes for you to navigate the slalom. Are you ready?
I'm ready.
You up for the challenge?
I can take 4 poles. Yes, I'm ready. Yeah. And, oh, you started. I move like a cat.
You did that quite well. You did that in 8 seconds.
Okay, not very difficult.
It's quite straightforward. Yeah. So I think we need to make it slightly more difficult.
Okay. So that's our control test. Simple enough. But how do you replicate the disorientation you feel when in space?
So what I'd like you to do now is to repeat that, but with these displacement prisms. Just pop them on.
Yeah, these don't look like... This looks like gaffer tape on a pair of old welding glasses. But I'll wear your displacement prisms. Oh, wow, that is... Yeah, you're there. No, you're there. No, don't move. Don't add to it. Right, how far off are you, by the way? These glasses shift your vision by 30 degrees, which mimics the disorientation that astronauts have to overcome.
So you think you can do the slalom course now?
Yeah, absolutely. No problem at all. First time. You tell me? You tell me?
Off we go then.
Okay.
Oh dear. Hitting the poles is disaster.
Okay,
You've
fine.
crashed.
Okay. This is exactly as difficult as I am making it look. Ah, Jesus. Just to see if I went and tried to do the other way around. Ooh. Yeah. Oh, that was close. Oh, it's actually this is the very first one I've done and the others didn't count. Shall we go?
3, 2, 1, go.
See the man master the task.
Excellent.
Thank you very much. So how fast is that?
So this time you did it in 15 seconds.
Okay, that's almost twice as slow. Now that I have this down, how do we make it more difficult?
Okay, so one of the things that astronauts have to do is they have to get instructions from mission control
Okay.
or from other members of the crew
Yep.
and have to do the right thing. So what I'd like you to do now is to do a cognitive task where you count down in 7s.
What number do you want?
From 493.
Okay. So with the extra complication, this time in theory I should be even slower. 493.
Are you ready?
Yes. Go. 493, 486, 479, 472, 465, 458, 451, 444, 437, 430, 423, 416.
Okay.
How long?
Did that actually quicker. In
Really?
12 seconds. So maybe,
Quicker?
maybe it focused the mind.
I was faster. I was 20% faster by doing both tasks than I was originally.
Yes.
Have I killed science? Is that what you're saying? 12 seconds, my friends. Read it and weep. All of your life's work is for nothing.
Disappeared.
I've destroyed it, my friend. Thank you. I am the winner. And he walks into a pole. Literally none of you were expecting that, were you? You thought I'd get worse and worse and worse. Yeah, I am too good to be an astronaut. That was all about disorientation. I mean, that is presumably the key issue.
Yeah, I mean, you watch that there, and it's obviously, as the commander of the ISS said, it's a challenging, disorientating environment. So is there a sense of trepidation? I suppose everyone always asks you this, but it's an unnatural thing to do in a sense, isn't it? So how do you feel about your first space flight?
I'm thoroughly looking forward to my first space flight, but yes, I think it does take normally about 1 month to become fully adapted to space flight.
And you don't feel, but I mean, I can ask you again, because most people would think, I asked an astronaut this once, I said, do you feel scared? And the first thing he said was no, because I have to do my job and I have to block it all out. But then he said, actually, anyone who sits on top of X thousand tons of liquid hydrogen and oxygen doesn't really understand the problem if they're not a little bit worried about it. So when you sat on the launch pad on that Soyuz, it's the Russian launch site, isn't it?
That's right, yes.
What do you feel like? Is it just like flying a helicopter?
Well, I think that they aim to keep you so busy that you don't have time to get scared, but there'll probably be a couple of moments in the checklist where there'll be pauses, and I'm sure at that point there'll be a little bit of sort of trepidation.
Phil, if we were asking people to come in with questions, and that touches on some of this, Adam Burrows asked, he wants to know if astronauts get any free time, and if you do, what do you do?
Yeah, surprisingly, that was one of the questions I was asked in my selection process. What would I do on my days off? And I laughed, saying, well, surely you don't get days off. But Sundays are days off on the space station.
So what do you do?
Well, there is a keyboard, a guitar, there are books, DVDs, everybody has their individual laptops, iPhoning home to friends and family, blogging, Facebook, Twitter.
I suppose that's a performance thing, isn't it? I suppose it's true that if you don't have days off, then your performance degrades.
That's right, it's all part of the sort of psychological well-being of astronauts on long-duration spaceflight.
People ask things about what is space food like? Very common question.
Not too bad, actually. Everything is either in a tin or it's dehydrated.
But your taste buds don't work as well, am I right?
That's right, yes. Yeah, they don't work as well, and also you don't tend to digest the food quite as well.
I do like this one. Who cleans the International Space Station?
Saturday cleaning.
Really?
Yeah.
Inside and out?
No, just inside.
Okay.
But it's very important to get the air filters.
I have to ask you very quick. I mean, should we be on our way to Mars now? Should we be there? Why should we want to go to Mars and beyond?
Well, as you saw in the video clip there, I think it's very important for mankind to always push forward, push the boundaries, and explore further into our solar system and further into space. And it also has payback here on Earth. We end up with lots of different spin-off technologies here on Earth in terms of medical research and fluid physics and material sciences.
Absolutely.
Okay, thank you very much, Tim. Time now for us to nip back to Hawaii for our final visit. Liz is still at the United Kingdom Infrared Telescope. What have you got for us, Liz?
Thank you very much, Dara. We're outside the UKERT telescope with Professor Gary Davis. We're going to talk about deep space projects now, the best of what UKERT and JCMT are doing. First of all, let's talk about UKERT's work, the Deep Space Survey, and what this image is telling us.
Well, this comes from a project we're doing on UKERT called the Ultra Deep Survey. And the objective here is to map the formation of galaxies throughout the history of the universe. To do that, we have to look backwards in time.
Okay, so we use infrared, we use UKERT, and then what are we looking at with this fantastic
What you're looking
image?
at here is an image of one small part of the sky.
Yeah.
And apart from a few exceptions, most of the objects you see here are galaxies.
So there's a few stars here, and then galaxies, galaxies, galaxies. How many galaxies are we looking at right
There
here?
are over 200,000 galaxies in this image.
Incredible. And how old are some of these?
Well, they range in age because some of them are quite close to us, but some of them are actually quite distant. And the most distant ones in this image are something like 13 billion light years distant from us.
So literally they were forming at the beginning of the universe.
That's right.
It's taken them 13 billion years to get to us. So they were new then, they're old now.
That's right.
Oh, that's incredible. How do you look back in time with this kind of technology?
We keep taking images, exposures on the same part of the sky,
Yeah.
and we just stack them up, taking a long exposure. It's like taking an ice core through the Antarctic ice sheet to map the climate history of the Earth. It's a very similar process.
Oh, it's just a beautiful thing. And also, with regards to this telescope, or white pillar box at the bottom, I don't mean to insult your telescope, but JCMT is doing some incredible work. Tell me about this solar system and debris disk that looks suspiciously like the Kuiper belt around our solar system.
Yeah, this is actually a result from more than a decade ago now. But I said earlier that the JCMT is sensitive to very cold objects in the universe. And what we have in this image, that I hope the viewers at home are now looking at,
Yeah, we have an image for you.
is a ring of very, very cold dust in orbit around a star. And this star is actually very close to us. It's only 10 light years away.
Absolutely stunning. And JCMT is being upgraded as we speak, isn't it?
Yes, it is. We've taken delivery of a new camera based on the success of observations like we just talked about.
Yeah.
And this new camera is called Scuba 2. It was built in Edinburgh at a cost of £15 million.
Ooh, it better be good then for that
It better
price.
be good, and we're just getting it working now.
So better, more sensitivity, looking at things further away.
Yeah, and faster.
Incredible. So when it comes to the next step for astronomers, you know, is it a question or if or when with regards to Earth-like planets?
Well, Earth-like planets is a hot topic in astronomy, and it is a question of when,
Really?
not if. Oh yeah, this is not science fiction anymore.
It's just so amazing to be standing here. You know, during my own lifetime, I'm hearing an astronomer like yourself saying, "Yeah, no, it's going to happen."
Yeah.
With this technology, we know it's a matter of time.
Yes.
That is just
that's
wonderful.
Absolutely right. We know they're out there, and we know how to find them.
Wonderful. Gary, it's been an absolute privilege to hang out with you up here. Thank you so much for taking me here today.
pleasure.
And that's it from us, from Hawaii. I have had the journey of a lifetime. I have stood on the edge of a volcano, giving us hints as to the formation of all our terrestrial planets. I've seen the incredibly volatile solar activity of the star that keeps us alive. And then finally to come here and witness the work that astronomers are doing to discover more about our universe has been incredibly humbling and just awesome. Okay, I'm going to sign off now because I'm waxing lyrical. It must be the lack of oxygen. Back to you guys at Jodrell Bank.
Lovely stuff. Thank you very, very much, Liz, for finding the only American professor who's an Everton fan in Hawaii. It has been a brilliant 3 nights, and we've experienced, you know, solar eclipses and conjunctions and meteor showers, but there is still more to see.
Yeah, for the last time, let's pop over to Lord Tobin in the BBC Weather Centre to find out which part of the country is going to get the best viewing conditions tonight.
Hello there. Well, finally, after some very cloudy nights, I've sorted it out. Tonight, there's going to be a lot of clear skies around. This is our very latest satellite picture. In the south, it is cloudy, but north of here, we have clear skies. And for many, we keep these very clear skies through much of the night, particularly for North Wales, the Midlands, Northern England, and southern areas of Scotland. So from midnight 6, you see Saturn rising, and from 2:45, we can see Venus rising. And from midnight onwards, the skies remain very clear yet again. It's just the south where it will be cloudy. For everyone else, mostly prolonged clear spells, if not just a little patchy cloud getting in the way from time to time. Tomorrow night, more of the same. The south, unfortunately, cloudy. For everyone else, it will be clear, but if it's clear, it will be very cold. Worth bearing in mind, sub-zero temperatures, you're going to need to wrap up. So finally, I've sorted it out. There are clear skies, Dara and Brian.
Fantastic, clear skies. So get out there and have a look at stuff. We've had a fantastic 3 days. The privilege of geeking it up fully here in Jodrell Bank has been a joy. But there are loads of ways for you to still get involved. Go to the website for details of 314 different stargazing live events that are happening up and down the country. We finally, by the way, let Mark come in from the cold. Hello, Mark. This is what Mark looks like in actual light. What words of encouragement can you offer our viewers, Mark?
Well, there's going to be clear skies around the country, but you don't need any equipment to get out there and enjoy the night sky. Wrap up warm and get out there and look at the sky. But don't forget to look forwards as well as backwards.
Yeah, and look, thanks to Jonathan, and we've got to say good luck to Tim when he blasts off into space. You know, this is the end of the programme, but I don't think you should think of it as the end of your journey into astronomy, and I hope we've shown you, if you didn't think about the skies, if you didn't think what was up there in the universe, it's genuinely full of wonders. There are stars being born, stars dying. You know, lift your eyes off the ground when the cloudless skies are there, and think.
Yes, it's an incredible universe. It's directly above you. It's the easiest thing. What was your favourite thing of the last?
And the Andromeda Galaxy, those beautiful images, I thought they were fantastic. And talking to Tim, our future should be in space.
We'll leave you with some of the best viewer images that we've received the last 3 days. Keep watching the stars. Goodbye.
See you later.
Because he's got an extra set of eyes, and he's with Jonathan Ross. Hello, Jonathan, how are you?
I'm very well, Darrell. How are you? Nice to be here. Thank you for having me.
I know, one invite. Come up and join us and stand outside and be cold.
Yeah, please do.
How are you guys? You all right?
It's very, very good. Now, you didn't see it last night, Mark. You saw it afterwards. Were you surprised?
Yes, I was. I was completely oblivious to it. And I gather a number of the chat sites went mad for the appearance of this thing over my shoulder. And of course, I had no idea what was going on. I seem to make a career out of it.
Contacting us live who told us that thing had happened. And what are we going to see tonight?
Well, unfortunately, it's cloudy, but we're out here in our field at Jodrell Bank. I've got Jonathan with me. Now, last time we met Jonathan, of course, you have 3 complex computerised telescopes.
Thanks for reminding
You
us.
didn't really have much of a clue around how to find a way around the sky.
Because I tried and failed, frankly, but you took me by the hand very gently, very kindly, and now I do feel like I have the confidence to go out on my own. But you know, it was less cloudy about 5 minutes ago. We could see more about 5 minutes ago.
So do you feel like you've learned more?
I think, well, obviously I couldn't have learned less. I mean, I clearly knew next to nothing.
You've come away knowing something.
I think I can spot the occasional star, and even if I don't get it right, I'll bluff with a degree of confidence that will surprise me.
Little test for you. Do you remember this?
I do. It's the planioscope.
The planioscope.
Planiosphere thing.
Commonly known as a planisphere. Can you set it up for me?
Yeah. Well, right now?
No.
Well, I can't because
Can you remember
I've
how
got
to
good
use
excuse
it?
because I can't see the stars, so I can't find the North Star. If I could find the North Star, I could, because I set this, find the North Star, and put the time and date in matching, line it up, bingo.
So you have learned something.
Also remember
Your
it.
experience.
And I watched it back 2 nights ago.
And you.
This is the International Space Station, 280 miles up, passing overhead here at Jodrell Bank just a short time ago.
Yeah, the 6 astronauts on board are currently the only people in space. I've been talking to them as they orbit the Earth at 17,500 miles an hour.
Also tonight, the best free show on Earth, a meteor shower.
I'm Brian Cox. He's Darrell Breen. This is Stargazing Live.
Welcome back to Jodrell Bank in Cheshire for night 3 of Stargazing Live. Coming up later, we'll be meeting the next British astronaut going into space. And if you're with us for the first time, well, you're joining what I think personally is the highlight, the greatest free show on Earth, a meteor shower.
Yeah, this guy here, believe it or not, is older than planet Earth.
Yeah, they can pop up anywhere. As we discovered last night, while filming something completely different over Mark's shoulder, you saw one there. Hawkeye Mark Thompson is outside again, hopefully keeping his eyes peeled a bit more.
You've been revising, haven't you?
Yes.
How dare you, sir? You've been revising.
Because I'm interested in it. You've opened my eyes. I've read books and stuff. I know much more than I ever knew before.
Oh, that's great stuff. That's great stuff. Well, if the skies do clear tonight, then do hang around because there are still some amazing objects in the sky that you can see. Certainly, most of them are easily findable. Findable. It's not even a word, is it?
Findable.
Some great objects that you can find for amateur astronomers. Certainly, people like Jonathan can pick them up easily. So hang around, and hopefully, we'll see something new.
Yes, there'll be more from Mark Johnson and an entire universe of findable things later in the show. He's also got real-life astronaut Major Tim Peake joining us later.
Yeah, you know, I met Neil Armstrong recently.
Yeah,
One of the most astonishing moments of my life. Actually, there's some kids there as well, and one of them asked him, they said, what did it feel like, you know, when you landed on the moon and you were running out of fuel, you had about 10 seconds left, you landed on the Sea of Tranquility. And he said, you know what, when the needle is on empty, there's always a bit of gas left in the tank. And then he got a standing ovation. It's the right stuff. Anyway, if you've got a question that you'd like to ask Tim, or anything else you'd like to know, within reason, of course, email it to us at stargazing@bbc.co.uk.
Or you can join in our live blog, Talk Stargazing, at the website. And please keep your pictures coming into the photo group. They've been fantastic so far.
Well, all this week, Liz Bonin has been in Hawaii for us. It's one of the best spots for astronomical research on the planet. And today, Liz is going to show us why. Hi, Liz. Where are you?
Thank you very much, Brian. You joined me at the very top of Mauna Kea. Check this out. 13,846 feet. Now, we've got about 60% oxygen here, which means that I might talk a bit of nonsense, so please forgive me. I'm trying to breathe as much oxygen as I can, but take in this view. So many telescopes from so many countries. To my left over there, the silver one, that's the Gemini, USA, Great Britain, Canada, and a few other countries. Over there, that little silver one there is NASA's telescope. To my right, the 2 beautiful USA Keck telescopes. Beside that, Subaru from Japan. And down there, the thing that looks a bit like a pillar box in white, is our very own Best of British, JCMT. And look at it. You can kind of get why all these telescopes are here. The clarity, the atmosphere, the climate is perfect to get a view of the night sky like you wouldn't get anywhere else on Earth. Of all the stars that the Earth can see, we can view 80% of them from right here. And I got a chance to do just that at the very top of this mountain during the night sky. Beautiful stars. Take a look at this. Being a novice, I've asked astronomer Josh Wollevender to join me at the top. Josh works at the University of Hawaii and knows everything there is to know about the night sky. Hey Josh,
Hi,
nice to
Liz.
meet you. How are you doing?
I'm doing good.
It's already looking pretty spectacular up there.
Yeah, we're right at the end of astronomical twilight. It's finally fully dark, and
Okay.
we can see just about everything we're going to see tonight.
We're going to see some good stuff?
It's going to be fantastic. So tell you what, why don't we grab the camera and take some pictures and start playing around with it?
Fantastic, let's go. As twilight gives way to complete darkness, it's easy to see why all these telescopes are here. The sky lights up with more stars than I've ever seen before. So on a night like this, what are the main things we can see with the naked eye?
Well, what's really spectacular from here is the Milky Way, and if you look over this way, you can see sort of a, faint milky band moving through the sky, and this is all the distant stars in our galaxy. So here's the wide-angle shot. You can see the Milky Way, and what we can do is zoom in here, and part of the Milky Way, right next to it, is the constellation of Orion. And if you look very carefully, the central star in that sword of Orion,
yeah,
you see how that's kind of fuzzy?
Yeah.
That is an area where stars are being born. This is called a nebula.
Oh yeah,
and
fantastic.
that fuzziness is a cloud of gas and dust, and that cloud is the raw material of star birth.
He is surrounded by so many stars. It's literally overcrowded on a night like this, isn't it?
Right, when it's really dark like this, when you're in a dark sky site, the constellations are almost harder to pick out because you see so many stars. All right, what we're going to take a look at now is the actual farthest thing you can see with the naked eye. What it really is it's another galaxy. So just like our Milky Way is a big disk of 100 billion stars, the Andromeda Galaxy is another